Alright, in this problem we're going to do the same thing. Class, read it to me on the count of 3. Ready? 1, 2, 3.
Replace every x with negative x.
So I'm going to replace each of these x's with a negative x. Do that. Oh, that one was squared. Class, what's negative x to the third power? Negative x to the third, yes?
Yeah.
What is negative x squared? X squared. And then I have the 4 minus. I'm going to pull out that negative here. That's a negative 1, yes?
Yeah.
I'm going to pull that out in front. So this is a big negative sign. It's in line with the fraction line. Numerator, I have x to the third. And then denominator, I have 4 minus x squared. Class, do you see that somewhere? Is that equal to the original problem? Yeah. Every time you see x to the third over 4 minus x squared, what are you going to write? You're going to write h of x. I see x to the third over 4 minus x squared, so I'm going to write is equal to the opposite of h of x. When the problem is the opposite of what you started with, this is a odd problem. And I forgot the minus sign. Odd equals the opposite of f of x. Do you see that? Let's go ahead and graph it. So you have a rational function here. So when you're graphing rational functions, make sure you're starting with a, so the original problem's up here. You're going to put the numerator in parentheses. So parentheses, x, x, x. Close the parentheses, divided by 4 minus x, x. I'm going to press zoom 6, standard zoom, and you're going to get a crazy graph. Now tomorrow's lesson will be about actually how to find the horizontal and vertical asymptotes. But for now we can do some sketching. You'll probably notice some vertical asymptotes at 2 and negative 2. So let's go ahead and sketch that. Remember, the big idea is just kind of a quick sketch. So I have vertical asymptotes. Let's graph this in blue. So in this problem, it doesn't look like I can fold the graph on my pencil on the y-axis, right? Okay. This one, if you put a different colored dot right at the origin, everyone say origin? Origin. They call this symmetry at the origin. So let's write that where I'm going to fit it. Symmetry at origin. Here's an example. See if I can get the color. If I put the order pair 1, 1, and I go to the origin, down, and then left, and I make this same L here, what's that order pair? -1, comma, -1. What does that mean? If I put in an x value, a positive x value over here in the original function, I will get that same value back, a positive. We put in a negative x, and we get a negative as our answer. Okay, so they call this an odd function. It's an odd function because when you algebraically put in a negative x, you get opposite of the original function, or negative of that function, and it's symmetrical to the origin. You can probably also see tomorrow we'll talk about slanted asymptote. Do you see it? I'll put my pen right there.